Welcome to Sports Science Tutor. This is an exclusive SPSS tutorial series brought to you by Sports Science Tutor. For the rest of this series, please visit sportsciencetutor.com/SPSS. Scales of measurement. The variable view mode in the SPSS data editor provides a number of variable properties which we may want to change from the default settings. In this tutorial, we will look at one such property that we might want to change so that we can perform certain analyses. And that variable property is the scale of measurement. And in this screenshot of the variable view mode in the SPSS data editor, you can see that I've highlighted the column that relates to the scale of measurement, and so that's going to be the column that we're interested in with regards to today's tutorial. And if you recall back to the previous video, we mentioned that in statistics we are normally told that there are four scales of measurement. These are nominal, ordinal, interval and ratio, and the problem we highlighted was that when we click on a cell within the column that relates to this scale of measurement in the SPSS variable view mode of the data editor, then we are only given the options of ordinal or nominal data. There is no option for interval or ratio, and the reason for that is because SPSS has the same setting for both interval and ratio scale, and so if you're dealing with either of those scales of measurement, just select scale and you'll be absolutely fine there. So just select scale there and there'll be no problems. The only thing is you do need to have an understanding of these different scales of measurement and know which type of scale you are dealing with in order to make the appropriate selections. And so that's what I want to briefly touch on here, with perhaps one or two examples of variables that might fall into these different scales of measurement. So starting with nominal data, this is essentially where subjects are grouped into mutually exclusive categories. So there's no qualitative differentiation here. So gender, which is a variable that we've used as a previous example, might be an example of nominal data. One group's not necessarily bigger or better than another, they're just different. Moving on to the next scale of measurement, ordinal. This is essentially a rank order scale because it gives quantitative order to variables. So we can now actually say that one score is better than another score, but we don't necessarily know how much better. So an example of this might be finishing position in a race. We know that first place is better than second, which in turn is better than third place, but maybe the winner was a full minute clear of second place, whereas there might have only been maybe a couple of seconds in between second and third place. Finishing position alone doesn't provide you with this information, and so that's why finishing position would be ordinal data, because we're simply dealing with rank order. Moving on to interval scale, the distances between the measurements are now defined. And the distances have consistent meaning as well. So a good example of this might be temperature. If we move up the scale from 20 degrees centigrade to 30 degrees centigrade, we're talking about the same amount of heat difference compared to if we were to move down the scale from 20 degrees to 10 degrees centigrade. In both instances, there is a difference of 10 degrees centigrade. But there's no true zero in interval scale. That's what's lacking with the interval scale, an absence of a true zero. And so that's why temperature is an appropriate example here, because yes, we can record a temperature of 0 degrees centigrade, but it doesn't actually mean an absence of heat, because we can go below this with minus temperatures. -5 is lower than 0 degrees centigrade, and so there is no true zero, and so it's interval scale. And so this is where ratio comes in as probably the most complete scale of measurement. It has all the properties of interval scale, but it also has a true zero. So an example of this would be body mass, because a value of 0 represents an absence of mass. So if 0, a value of 0 represents an absence of a particular quality, then you can say that this is ratio scale, and that would be the type of scale of measurement that you would select in the variable view mode of the SPSS data editor.